This video is entitled Data Flow Diagrams, the Context Diagram. This is the second video in our discussion for Chapter 5, for Topic 5 in the Systems Analysis and Design course on data flow diagramming and process modeling. I'm Jim Renaud, PhD, from Shawnee State University, and I'll be taking you through this presentation. So in the last video, I mentioned what a data flow diagram, what a context diagram is, but a context diagram is the highest level data flow diagram. It gives us a really big picture of where the system fits. It's the highest diagram. It's the diagram looking at the Earth from the moon. It's just a little blue ball kind of vision of a whole system. It shows the system. It shows the really important external entities or sinks and sources of data and the data flows. If in the context of this class, kind of start with a context diagram. That's why I'm showing it at this point. I'd like you to kind of look at a problem and draw the context diagram. And then let's take the context diagram and decompose it into the level 0 diagram as we learn more about the problem. So let's start here and we'll decompose these these context diagrams into level 0 diagrams. So this is kind of a generic context diagram. I have three sinks and sources, or three entities, A, B, and Q. And you can see that data flows from A to the system, the context diagram. I don't know what that flow is, but I've named that data flow Z. Data flows from the system to B, and B sends data to the system. Now, I don't know what order the data is sent to and from the system, but that really doesn't matter. The system is going to send data to B, and B is going to send data back to the system. So B is a sink with X and a source with Y. Q over there, the reason it's got a weird letter is I wanted to represent it as a different system. You know, instead of being a person or a department or someone or something, it's actually a whole nother system over there that's interfacing with this new system. And you can see that it is both a sink and a source, that it's sending data over as V and getting data back as W. So this you can see is kind of a generic context diagram. And you can see these sinks and sources, these entities that exist outside the system that we're modeling. So here's a context diagram for a system very similar to a system I wrote for a client a couple of years ago. And this is a repair order system. So you can see that the system is here in the middle, just as 0, the system, and it says the RO system, repair order. And our four entities, our four sinks and sources for data are the service techs, the managers, the customers, and the accounts receivable system. So let's look at the data flows. How does a customer interact with this system? Well, the customer sends a status request to the system, and the system will send back a job status. So a customer should be able to send in a request. I want to know what's happening to my job, and the system should send back notes, statuses about where the job is. Also, the system is going to send the customer an invoice. Okay, so the system will generate an invoice and send it to the customer. Let's look at the sink over here at the end, the accounts receivable system. Notice that the repair order system is also going to send the same data that it sent to the customer, the invoice, over to the accounts receivable system. The AR system is going to handle deposits, direct deposits, credit cards, statements, late billing, terms, discounts, and all of that kind of stuff. And we already have an accounts receivable system doing that for other processes and other things that our business does. So why wouldn't we just let it handle it? Why wouldn't we just let the accounts receivable system handle when people pay and how much they owe and all of that? So yeah, that's not in our system. That's in a different system. So we're going to send the invoice when the invoice is done out to the accounts receivable system. And then when the customer pays, the customer will pay the accounts receivable system. But we don't see that because we don't have data flows from customer to customer. That would be the accounts receivable process. So a manager, it looks like a manager enters jobs into the system. So a manager will sit down and will type in the job information. So the manager will meet with the customer. The manager will make notes about what the customer wants. The manager or salesperson will decide what all it's going to do, and they're going to enter that system into the repair order system. The manager can also do a report request or request a report or multiple reports from the system about job statuses, costs, employees, efficiency, and all kinds of other things, and they'll get those reports back. So you can see that data flow of reports is a huge complex because it contains all the reports that managers can get and all the attributes and fields and columns and rows, and just it's huge, that data flow. Um, so there you can see how the manager is going to interface with the system. And the last entity I want to mention is the service technician. How do they interface with the system? Well, the service tech is going to be sent a task to do. So the repair order system is going to say, hey, you go do this. It's part of this job, but the job is made up of lots of tasks. My client is a hydraulic cylinder manufacturing company. So when they repair a hydraulic cylinder, there's the breakup task where you got to tear it apart, and then there are seals that got to be replaced, and sometimes you've got to rebuild pieces and weld things and polish and grind and all kinds of things are involved. So those are tasks, and a job is made up of many, many tasks. So a task is sent to the service tech, and the service tech then sends back to the system the time he or she spent on the task. I spent 3 hours on the task today. I spent 2 hours on this other task today. So that the system now is tracking how many hours are spent on each task, whether the task is finished or not. And notice that the service tech also sends to the system a list of materials used on a task. So if I needed a washer, that would be on the materials. Or if I needed a rubber seal, that would be on the materials. Or if I needed a hose, that would be on the materials. So that the repair order system is tracking all of the stuff we use on the job also, because it's tasks are part of a job and materials are on the task. So you get the kind of idea. So that's the system in the context level. Let's look at it drawn pretty. This version of the very same diagram was done using a program called draw.io. Go online, you can download it for free. You can use the cloud version online, or you can download an app for your PC, your Mac, your Linux box, your Android tablet. There's an Apple tablet version. Just it's a great piece of software, and the shapes that are here are on these are all shapes that exist in the Draw.io program under the entity relationship diagramming toolkit of shapes. So you can see that I have my shape in the middle, my system, because it's a context diagram, and I've numbered it number 0, and then I've called it the repair order system. I then have the customer and their 3 data flows. I have the AR and its data flow. I have the manager and its 3 data flows, and the service tech and its 3 data flows. So I scribbled it out on a piece of paper, scribbled it out on my blackboard here, and then sat down in front of the software and created a really beautiful, professional looking diagram to represent this context, or the context of this proposed system, or the system that we're going to be working on. You know, it's summer, and one of the things I love more than anything else in the universe is ice cream. So this example is the context diagram for the imaginary ice cream stand I'm going to open when I retire. So the system will be the ice cream stand point of sale system, the system that's going to run the ice cream stand. So let's look at it. The customer will tell the system the order. Now, actually, the customer is going to tell us verbally what it is to a process, but also in that process, there's going to be my customer service person, my person at the window, or the customer could enter it on the web interface or on the smartphone app and go directly into the system. So you see the customer could enter it directly into the system. The system is going to tell the customer what the order amount is. It's going to say to the customer, well, that was $324. That's a lot of ice cream. But the system will calculate the order amount and then send that order amount back to the customer. The customer will then send the payment into the system. Credit card, hit the numbers on the dashboard, hand cash, which would go to a process, because cash and the amount of money is data, isn't it? So that would be what the customer does. Let's look at the bank. What do I have a bank here for? How's a bank involved in an ice cream stand? Well, what happens for those credit card charges? Those credit card charges have to get sent to the bank, and the bank sends back an approval. And then the bank puts it in my checking account, but that's their system. That's a different system. That's not in this system. That's in a different system. So the bank would then send back an approval to the system saying, yep, his credit card's good. He can have his ice cream today. Or his credit card barfed. He can't have his ice cream today. Send him away till tomorrow. So you can see there are the data flows to the bank. Let's look at this data flow up at the top. This entity up at the top. And I say there's an entity called kitchen. Now, if you think about most dairy bars you walk up to, if you order an ice cream cone, the person that took your order is going to go get the ice cream cone, or make your sundae for you, or make your milkshake for you. But if you order a footlong, if you order some fried cheese, if you order some fried pickles or funnel cakes or anything like that, they have to send that order back to the kitchen, and the kitchen will prepare it and then send it back out to the front. So I want the system to automatically send that food order, that food item, to the kitchen to be prepared. To say, hey kitchen, I need 2 footlongs with everything. Sounds like dinner to me. I need 2 footlongs with everything. And the kitchen, when it's done, is going to tap on the board. That order is complete. And boom, the kitchen will, on a screen, tell the system that, yes, in fact, the food is done. Then lastly, I have an entity here called the supply company, or a sink called the supply company. I want my dairy bar to be a little bit more automatic. I want it to automatically place orders back to my food supplier for things I need. For instance, when I'm right before I run low on footlong hot dogs, I want it to automatically order footlong hot dogs. I want it to automatically order the buns. I want it to automatically order the vanilla soft serve liquid. I want it to automatically order cups and spoons and and all that kind of stuff that goes with. So the system will generate that order and send it out to the supply company. So there's the context of my ice cream stand. Now, you wouldn't know that without interviewing the owner of the ice cream stand. You wouldn't know all of this without spending some time doing some analysis and getting this idea. And once we get this, we'll move on to the level 0 diagram in the next video. Here is a pretty version of that hand-drawn diagram using, again, the draw.io program with the customer, kitchen, supply company, and bank as the entities, as the sinks and sources, the system in the middle, and it probably should have said the ice cream stand system or Jim's ice cream system. And you can see each of the data flows. The customer sends in the order, gets back the order amount, the customer makes the payment goes out to the credit card company, the bank sends back an approval, unless the customer pays cash, and then that process won't happen. Food items get sent to the kitchen, and the kitchen tells us when the food is done, and our replenishment orders get sent out to our supplier. So you can see the context of the system, understanding the data flows and all the data that's flowing around in this system. This concludes video 5B, the context diagram. I'd like to say thank you for watching. Remember, this video is copyright 2020 by James M. Renault, PhD. All rights are reserved. You can contact me at jrenault@shawnee.edu or jem@renejm.com. And again, thanks for watching. Hope to see you in a subsequent video.